All right, hey everyone, this is the recap video for week 26 hobby kernel dev. This is where I debug my ELF loader, and it's a recap of like the hour and a half stream or hour 15-minute stream for those of you that don't have time to watch the whole thing. Basically, it was a very focused stream. The key point was to debug my ELF loader, which was causing triple faults and rebooting the machine like all the time. And I was able to do this successfully. So I just kind of intro at like 30. Yeah, I just kind of, I jump right into it. But starting, yeah, I mean, I just kind of get right into it. I first start by kind of just sanity testing and making sure that I have an idea of what part of the code is triggering the triple fault, and I kind of narrow it down to this section where I'm doing a lot of the core ELF loader loop, and I observe that I don't hit this panic 333. So something is going wrong with this loop. And I'm adding some more of these debug prints here to check the program headers. I'm also kind of verifying actually that my bug fix from last week worked. So I had this bug where I wasn't computing the program header pointer correctly, but now I'm printing out the program header members to verify that against the read ELF output, that I'm actually parsing those correctly. And that is what I'm doing here. So you can see that I have my program output and then the read ELF output, and I'm verifying against the load headers. So I move on, then I start kind of like bisecting using panics where the reboots happen. And I just do this by kind of inserting panics along and just kind of seeing at which point it panics rather than rebooting. All right, looks like VLC stopped scrubbing, which is kind of unfortunate. Do I have to press play? Okay. Please scrub again. Okay. Okay, that's unfortunate. Okay, man. Maybe I need to just pull up this thing.
All right, welcome back.
Okay, stop. Okay. So now there's so many me's on the screen right now. All right, so now I'm just kind of scrubbing through this. So I was doing panics to bisect where the problem is within this ELF loader loop, because I suspected it happens around here. So I was confirming exactly where the reboots happen and where like the memory access that causes the triple fault happen, just to kind of narrow it down on really what part of the code is triggering the bug. And yeah, so I'm adding some more prints. I'm checking some of these definitions of some of the ELF structure members to make sure I'm correct. I'm just going to kill this palm tree thing. And I'm correct in my interpretation of how to use this data, like how to actually use the offset field and stuff like that. So kind of walking through that. And so now I'm bisecting a bit more. So now here I added this if statement because the first run through the loop worked. But then it crashed on the second run of the loop. So now I don't want to panic. So now I can't just unconditionally panic inside this loop. I need to only panic if it's on the second iteration. And that was the tool I was using to kind of further my bisect. And that's when I discovered that on the second iteration of the loop, the mem set was causing the reboots. And so that really specifically narrowed it down for me. So that was like the first part of the approach, is just to very concretely specify where is the bug coming from. And luckily this is a totally deterministic bug. So it's in that class of bugs which are easier to debug. So I figured that out. And then I actually just updated my kind of mental model and my image with the actual data from this specific program header, this specific load segment, in which case the file size and the mem size are actually equal, just to have a more concrete understanding of the exact situation that is happening. And then I am kind of like looking through these things, and I'm observing that this is around the 23-minute mark, that the interesting thing about this program header is that the v-adder is not page aligned. And I wasn't thinking about that really when I was writing the code. And that ended up being very important. And so I made this new visual to kind of help me also understand this alternate kind of, I guess, execution possibility where alignment is not guaranteed for the virtual address. In this case, it's still a single page, but the data just doesn't start at the beginning. And then I was looking into region alloc, which I thought might have a bug with some of this rounding stuff, but I kind of moved past that. And then I eventually, using the prints, figured out the reason. It's just because I was just doing the math wrong, and I was inappropriately computing the distance of memset. I was inappropriately computing how far I had to memset, basically. Maybe I actually didn't quite get there. But yeah, here's the illustration. So basically, in this bottom line, that's how the code was working. It would take the end of the allocated region and subtract the mem size member, but that totally doesn't take into account that there can be some padding basically at the start. And therefore, if you take this distance they compute and then memset from a different place from the actual v-adder plus the mem size, you'll overshoot the page and write off into unmapped memory, which is exactly what was happening for me. So I understood the bug around 30-minute mark, and then started playing around with some ideas for how to fix it. I ended up deciding on an approach where I do all of the math purely based on pointers. I compute an end pointer that's really at the end of the allocation. I compute the pointer that's the start of the region, which should be memsetted. And then I just do subtraction between the two. And that ultimately would be the working solution. Yeah, I don't know what I'm doing here. I think I had a bug where I computed the end pointer incorrectly. And so I was fixing that around the 37 mark. And yeah, just updating the visual. And I was also trying to do this thing. I noticed that I actually had a second bug too, that I was forgetting to zero out this region. If there was not page alignment, I also need to zero out the region before the segment data begins, because otherwise that's a security issue. And I had this idea to actually poison the memory with some poison bytes, so I can visually observe this in the debugger, that a bunch of this region has not been zero initialized. And I went on a little bit of a side quest around 44-minute mark to actually implement this in my memory allocator. And I actually introduced a bug in the process of doing that, because I did it kind of naively, and that kind of interfered with things, but I didn't spend too long on that. I kind of recognized it pretty quickly. And then I eventually fixed the bug. I correctly poisoned the allocation, which requires a few details about juggling the CR3 register. You can watch that at 48-minute mark. And then from there, I kind of just wrap up the stream. And just verify everything. And so I use the debugger and I verify that there's these poison bytes. You can see the 42s everywhere. I verify that that there's the 42s at the beginning. So here's me verifying the bug where I forgot to zero out the start data at the beginning of the page if it wasn't aligned. And then I fix the issue and just one more time go through that and verify it in the debugger. The 42s are there. And then this time it's all zeros, which shows that this other bug is fixed. And that's it. That's the end of the stream. So yeah, thanks a lot for watching this recap. Let me know if you enjoy the recap format of these streams. And I'll see you next week for week 27. Thanks a lot. Bye.